recorded. And now I would like to present our lecturer today, Dr. Victor Acha. He is from the Institut Polytechnique LaSalle Beauvais in France. Currently, he is an associate professor of bioprocess engineering, biodetection technologies, and nanotechnologies. He got his bachelor degree in chemical engineering in San Francisco Xavier University in Bolivia. After that, he did his master's and PhD in food engineering and in bioengineering, respectively, in the Catholic University of Leuven in Belgium. He also worked at the Mexican Institute of Oil on the treatment of oil effluents. Also, he worked at Colorado State University in the United States on the development of biosensors for environmental applications. Dr. Acha also worked at the University of Texas Health Science Center in San Antonio on the development of biosensors for biomedical applications. And his research interests include treatment of polluted waters by ozonation, bioprocess modeling, model-based estimations, development of simple, fast, and low-cost methods for measuring biomolecules, and the main application of such methods are in real-time monitoring and in developing of sensors and biosensors. And Dr. Acha is also the permanent member of the research unit Hydrise at LaSalle Beauvais. And we are very grateful that he is here with us today to present this lecture. And now I will give the screen to Dr. Acha. Hello, Victor.
Yes, I'm here.
Hello. Welcome.
Yes. Hello. Hello.
Series.
Okay. Thanks. Thanks again. Okay. Hello. Are you hearing me?
Yes. Yes.
Okay. Okay. Good. Okay. Thank you very much, Belishka.
Thank you for
presenting
today. Yes.
Okay, thank you very much, Belishka. And hello, everybody. How are you today? Well, it's great nanotechnologies applied in food and agriculture. In fact, this is a part of a regular lecture I give at the Polytechnique Institut LaSalle Beauvais. Beauvais is located somewhere in France at approximately 70 kilometers northern Paris. Here is the LaSalle campus. This institution offers 3 specialties: food and health, agriculture, and geology. Okay, here is the plan for today's presentation. First of all, I'm going to talk to you about basic aspects of nanotechnology for you to understand why nanotechnologies are being used everywhere in every sector. After that, I'm going to talk to you about the applications of nanotechnology in agriculture. In fact, some illustrations, some examples, and also the applications in food. And I'm going to talk to you a little bit about the risks of the application of nanotechnologies. And at the end, I will summarize my presentation. Okay, we human beings, we are the best example of the power of atoms. Once they can give us surprising behaviors, surprising structures with surprising properties. Let's give an example to understand this. Let's compare diamond with graphite. Both have 40 atoms of carbon, but why they are different? Well, because diamond presents a very nice configuration, a very solid configuration, which makes it stronger than graphite. Okay, what if we can choose a property, for instance, to destroy cancerous cells. And for this, we can use atoms to combine them in a suitable way in a special configuration to get wide combinations of atoms to generate molecules, and then to combine with the necessary material to make it possible, to make possible this way. By the time being, there are the so-called methods of chemotherapy methods, in fact, to destroy cancerous cells, right? But these methods have some problems. The side effects they produce when we release the chemicals, right? So the idea is, by combining atoms, by creating these special structures, to create the so-called special targeted delivery systems in such a way to avoid the side effect in this precise case, to destroy cancerous cells. We can also control, for instance, the release of pesticides or herbicides in such a way to avoid the pollution of the environment. We can also think to remove pollutants from the environment by using the same devices, nanostructure devices. Okay, the question is, our
Hello?
We analyze the sensitizing. How this shows.
Victor, we have a problem with the sound.
No, in more detail the chemical composition. Hello?
Hello?
May I go on?
We lost your sound for a while. So,
Okay,
can you please start again with removing pollutants from the environment, because that's where we lost.
Okay. Well, okay. I was telling you, by creating this special targeted systems, we can train to, for instance, control the release of pesticides to avoid the pollution of the environment. And by using these same systems, we can dream to remove pollutants from the environment too. So the question is, oh, it's not working, sorry. The question is, our dreams, to say the matter, according to our desires, can become a reality? Hello, are you hearing me?
Yes, now it's better, but we have also a lot of background noises from your office. I think.
Yes, I. It's not my office. It has to be.
Okay, let's continue. Maybe if you remove your headset and try with direct microphone.
My headset. How I want to.
Okay. You're with such.
Okay. Wait a minute. Okay, now it's possible to go on?
Yes, let's try.
Okay, so I was telling you that, well, there was a question. So our dreams can become a reality. So by the time being, we analyze better than sensitizing. That's true. We are champions, for instance, to determine the chemical composition of particular structures. But we don't know how these structures function, how they work. We are not yet able to understand, to find out the links between the molecular, the molecular and microscopic state. All we can say by the time being is that the macroscopic reality seems to come mysteriously from the nano or an atomoscopic state. And here is where nanotechnologists play a very important role. They are charged to design and fabricate custom-made materials, having precise functions, having precise improved properties. For instance, in this way, it's possible to fabricate two materials which are much more stronger, lighter than macro materials. I mean, materials which are more energy efficient, better at conducting electricity, much more reactive, and so on. So, the question is, in fact, what is nanotechnology? We can find several definitions in the literature and scientific papers, and here we have one of these definitions. Nanotechnology can be defined as the creation of functional materials, devices, and systems. How? Well, first of all, we need to understand and control this particular dimensions from 1 to 100 nanometers. The qualities and properties of matter are observed and can be harnessed for a broad range of applications. I mean, materials with improved properties, as I already told you some time ago. Okay, nanotechnology is the science behind the ability to build anything atom by atom to get nanostructures with particular properties. And this from the bottom up. Nanotechnology is not miniaturization. Okay, this is an illustration of the nanoscale. If we compare three aspects, we're going to conclude that, for instance, a football is 10 million times smaller than our planet. And if we compare a football with a nanoparticle, having in this case 0.7 nanometers, the nanoparticle is going to be 1 billion times smaller than a football. Okay. Let's understand the nanoscale. Let's compare our nano world with the nanoscopic world, this tiny world, to our world, the macro world. Laws that govern the nano world are entirely different from those compared to our macro world. At the nanoscale, the importance of gravity decreases, while the importance of van der forces among atoms or molecules increases. In other words, in the nano world, gravity doesn't know or has no effect, but the van der forces of attraction or repulsion are more and more important. Okay, let's illustrate this. I mean, any change of scale of a particular object is going to be accompanied by a radical change of its properties. For instance, if the size of a particular object is reduced in a factor of 2, its surface will be reduced in a factor of 4 to exponent 2. And its volume is going to be reduced in a factor of 8. Okay? Okay, let's understand better the situation. Consider a man of 1 meter 80 centimeters height, 80 kilograms weight, and well, this guy is the regular man can lift and rise about 80 kilograms, right? Okay. How about if we reduce his height in a factor of 100? So his new size is going to be 18 millimeters after calculations. His force, which is proportional to his muscle surface, will be reduced in a factor of 10,000. Thus, he will be able to rise a weight of 8,000 milligrams. Okay? His weight now, which is proportional to his volume, will be reduced in a factor of 1 million. Thus, his new weight is going to be approximately 80 milligrams. So, a tiny man of just 18 millimeters is able to lift 8,000 milligrams, having just a weight of 80 milligrams. So, he can lift a weight of 100 times his weight. What happened with this little man? Well, he became strong, stronger than a regular man. Now, if you continue to reduce his size, for instance, going to the micrometer level, after calculation, the same calculations, you're going to realize that this guy is going to be able to rise 100,000 times his weight. He is more and more strong. Now let's go to the nano scale. Let's consider a man having just 18 nanometers. He will be able to rise 100 million times his weight. That's amazing. You see how nanoparticles present, or they are stronger than the macroparticles, and other properties in this way can be also improved. Okay, let's study now another property of nanoparticles, the so-called high surface area to volume ratio. For this, let's consider a cubic nanoparticle of size A. So we can write down the equation representing this surface area to volume ratio. So this is the surface area of this cubic nanoparticle, and this is the volume. So we get this equation. It means that the surface area to volume ratio is inversely proportional to the size, to the side A of this cubic nanoparticle. Let's illustrate this. We're going to use this equation. First of all, A equals 2 meters. So the surface area is going to be 3, keeping constant a volume of 8 cubic meters. Now let's change the side to 1 meter. The surface area to volume ratio is going to be 6. And so on, half a meter, 12, and let's consider now a size of 1 nanometer. This is 1 nanometer. The surface area is going to be huge. You see, 10 exponent 9. It's a huge area, which is very important. It means that these particles at this scale, nanoscale, present a huge contact area, very important for several applications. Let's see now nanoparticles, spheric nanoparticles. We can proceed with the same calculations to get, first of all, an equation, and we're going to get the same conclusion, inversely proportional to the, in this case, to the diameter A, right? But anyway, these spherical nanoparticles, they are going to present also a huge contact area. Okay, what are the consequences of this property? Huge surface area to volume ratio. Well, it's a manifestation of novel phenomena and properties. Physical properties are going to be changed. For instance, the melting point is going to be reduced. The nanoparticles are going to become more and more reactive, very reactive in fact. And well, their electrical properties are going to be improved too, and mechanical properties is stronger than macromolecules, and optical properties too. Okay, some illustrations now, some illustration about this effects, improved properties. Here we have the melting point of gold nanoparticles. We can see that as the diameter decreases, the melting point decreases too. Okay, and here you have the so-called nanocrystals. You can see as the diameter decreases, the color changes more and more. Right? This is a very important property again to develop, in a special case, to develop sensors of biomedical applications. Okay, until now, let's summarize a little bit of what I want to explain to you. So first of all, the configurations of atoms, the spatial arrangement of atoms produces new materials with new functions with improved properties, right? That's how I saw you in the beginning. And then the reduce of the size of the object has
Hello?
And
Victor? Victor?
Hello?
Okay, now
Yes.
it's fine. Yes, we lost you
I'm here.
at...
Yeah.
Yes. Could you please again do
yeah.
the
Okay.
summarization?
Okay.
Summary?
So there are three situations. First, it's yes. There are
Okay.
three properties I was explaining to you. First, are you hearing me? Hello?
Again, it's interrupting. Maybe wait a little
Oh,
and try.
I don't know what's going on. Yes.
Yes, it was working well at the test, but technology is giving us hard time. Yes, please continue. I think now it's fine.
Okay, so let's summarize. Well, the configurations of atoms, I mean, the way they are arranged, the way they are configured, is very important for changing these materials and improving their properties. The second one was the rotational size. I told you the nanoscale gravity has no effects, and the most important forces are the van der Waals forces of attraction among molecules and atoms. That's very important too. We've seen that this makes nanoparticles stronger than macromolecules. And finally, another property is the huge surface area to volume ratio. So presenting a huge content area is very important for several applications. Okay, let's move on now. So thanks to these three properties, now you can find several applications in each sector. I mean, information technology, energy, medicine, and consumer goods too. Okay, let's study some nanoscale materials, nanoparticles, and structures. Well, first of all, gold nanoparticles. These nanoparticles are used for several applications, and in labeling, in delivery, in heating, and in sensing to identify, for instance, bacteria. Silver nanoparticles. Okay, these silver nanoparticles occurs naturally. They are considered non-toxic, non-allergic. They are not cumulative, and they are not known, as far as I know, to harm either wildlife or the environment. So no problem for use these nanoparticles. I can give you an example of the use of silver nanoparticles. These particles, having antibacterial properties, are used in our socks to kill the bacteria associated with our smelly feet. They can easily leak into wastewater during washing, for instance, so no problem for use them again. Okay, another bio-nanomaterials. Polymers based on nanostructures can be developed to develop synthetic organs. In this case, there is an illustration of a synthetic bone by using polymers as nanostructures. So the idea is to use cells and to put in the special structures, and once cells are acclimated to these structures, they can be transplanted in our bodies. Okay, some nanomaterials, such as nanowires and nanotubes. These structures, nanomaterials, has dimensions from 1 to 100 nanometer. So they present both the property I have already explained to you. So they present a huge surface area to volume ratio, which makes them usable in a lot of applications. Here I am presenting to you an application in solar panels. The nanowire materials, here you have the nanowire, presents a huge, again, area to volume ratio. So they're applied in the solar panels in such a way they are going to get much more energy from sun, so much more solar energy. That's the idea, to improve the absorption of energy. Okay, more materials, nanomaterials, for instance, fluorines. These amazing structures, well, they seem to be footballs, right? They were found accidentally when they vibrated graphite with a laser. They found these structures, carbon containing 60 atoms. Carbon nanotubes are very similar to fluorines, but they have a cylindrical shape. And so on other materials, gold nanoparticles, nanocrystals, and so on. Okay. Here again you have the carbon nanotubes having a diameter of 2 nanometers compared to other structures, graphite, diamond, fluorines, and some properties of carbon nanotubes. So let's compare to aluminum. You can see that carbon nanotubes are lighter than aluminum, right? They are stronger than steel alloys. They're really stronger. And they present a huge ability to carry a lot of electrical current, much more than the regular copper wires. And they have, for this several applications. For instance, in the design of semiconductors, chemical and genetic codes, and so on. Okay, quantum dots. Quantum dots are also nanomaterials. They are, in fact, fluorescent crystals presenting the property to emit light in response to an incident light, in this case an UV light. So these quantum dots emit light with different colors. Here you have a real nice explanation. So they can be used as markers in our bodies to tag proteins and nucleic acids. When UV light is shined on a sample, the quantum dots glow, indicating the locations of attached proteins, so yielding substantial information. So this signal, again, can be of different color. It depends on the applications. Okay. Why nanotechnology is being applied in food and agriculture? Well, nanotechnology is transforming the entire food industry from production to consumption. There are a lot of companies working in research and development, applying nanotechnologies in these particular fields. And well, the European Union has some challenges to get suitable answers to the growing demand for healthy and safe food. The situation is a little bit different in developing countries which are facing food shortages. So the idea would be to apply nanotechnologies to develop nanodevices which are going to make it possible to develop drought and pest-resistant crops, for instance. Why? Well, to combat the viruses and other crop pathogens. In such a way to maximize yields. Okay, nanotechnology presents new tools. It's able to provide smart sensors and smart delivery systems in such a way to enhance the ability, for instance, to plants to absorb nutrients. And again, as I have already told you, to combat viruses and crop pathogens. In the near future, it's going to be possible to develop to use nanostructural catalysts to develop very sensitive sensors, thanks to the third property I explained to you. I mean, the property to present a huge contact area to make catalysts more and more reactive. So these catalysts will be available to increase the efficiency of pesticides and herbicides. In such a way, it's going to be possible to control their doses to avoid the environmental pollution. Nowadays, there is a method, the so-called controlled environment agriculture, which is in fact an advanced and intensive form of agriculture. Plants are grown in a controlled environment so that horticultural practices can be optimized. So this system is composed of a computerized system which monitors and regulates the fields, the fields of plants. In this way, it's going to be, for instance, possible to determine the best time to harvest, to determine the vitality of crops, of plants, the probable contamination by chemicals or viruses, thanks to the use of smart sensors. Okay? Okay, composed of these nanostructural catalysts. Okay. Precision farming is a special method which was developed to maximize outputs, for instance, to maximize the crop yields, while minimizing the use of chemicals, in this case, fertilizers, pesticides, and herbicides. How? Well, through the monitoring of environmental variables and through targeted actions. Okay. It's going to be, again, to develop chemicals. For instance, pesticides, herbicides are going to be dissolved in water or nanoemulsions. So they are going to be encapsulated in these nano devices in such a way to control the release. It's a special way to control the release of these chemicals. So by developing these special targeted delivery systems. So precision farming is composed of smart agricultural systems. So it's necessary to use computers, GPS, and remote sensing devices. Nowadays, GPS are going to be, I think, replaced by the so-called drones. Apparently, drones are much more advantageous compared to GPS. Well, anyway, let's follow this presentation. Using this kind of precision farming is going to be possible to decrease the production cost and increase in productivity. And well, maybe the question is going to be how, for determining, for instance, whether crops are growing at maximum efficiency or identify the natural allocation of problems. That's the purpose of the GPS systems of this precision farming. So for this, it's necessary to use to develop smart wireless sensors linked permanently to GPS, and this way to allow real-time monitoring for early warning system. Okay, sensors. I talked to you, I mentioned, several times the word sensor. So what are sensors? In fact, sensors are based on the use of carbon nanotubes or nanocontrollers, for instance, so exogenous nanomaterials, which are small enough. They have a nano size to trap proteins or small molecules bacteria, viruses. So the chiral nanotubes or nanocontrollers interact with the molecules we analyze, we have to measure, by providing an electrical or chemical signal. This signal is going to be integrated in the detector before sending to the screen of our computers. Okay, let's see some illustration of applications of this. The first application is the so-called plant growth regulator. It was developed by Syngenta. Its name is PrimoMax. This was done to deliver chemicals in a controlled and targeted way by encapsulation, nano devices, nano emulsions, or pesticides. This was applied on grass, on top grass. Another application is the aluminum oxide nanofibers. Was developed by NanoSerum, and this is for water purification by using nanofilters. These nanofilters can remove viruses and bacteria from water. More applications. For instance, lanthanum nanoparticles can absorb phosphate from water. Very interesting applications which can be used in ponds, rivers, swimming pools, and so on. Nanoscale iron powders can be used for cleaning soil and groundwaters. The so-called bioremediation or nano-remediation in a proper way. So iron is used in this case. Nanoparticles of iron can oxidize these organic compounds. Okay, another illustration, the insecticide blockbuster, again developed by Syngenta. Well, it is an encapsulated product that breaks down just in alkaline environments, such as the stomach of insects. A very smart method to kill insects. Okay, more applications. But now in food. So again, the same question, why nano? Well, it's possible to develop, thanks to the use of nanotechnologies, smart packaging, on-demand preservatives, and interactive foods. Okay, what are interactive foods? Well, these foods are developed to allow consumers to modify foods depending on their nutritional needs. There are some people who present allergies to some nutrients, so this is appropriate for them, this kind of interactive foods. So it's possible to develop nano capsules containing flavors, colors, special nutrients, and producing these allergies, also vitamins and so on. These products, these nanocapsules, remain dormant in a food, and they are released just when triggered by the consumer. Small packaging. So this is useful to increase the food shelf life by detecting in an early way spoilage, bacteria, or the loss of nutrients. This is done thanks to the use again of smart sensors composed of nanostructures having special properties. So here we have the smart nano capsules, which can be incorporated. It's another illustration in food to deliver, in this case, tuna fish oil, and in the good nutrients, omega-3 fatty acids. Again, the capsules break down only in the stomach, so they are targeted nano devices used to apply in food. The addition of nanoparticles to existing foods also can be done to enhance absorption of nutrients, to change the color, or to change other properties of the food. Okay. Nano is already in food. I have already explained where. Well, the question is, where? And the answer is, well, this equation. Where's the nano? Well, lack of labeling laws. By the time nowadays, there is no labeling laws. Plus the secrecy in commercial use. That's true. People manufacturing food don't have an interest to indicate in the labels the use of nanoparticles because, well, people are a little bit scary to know that some nanoparticles were incorporated in the foods. Some applications, for instance, a nutritional drink composed of nano-iron drink for toddlers. The advantage of these drinks is, well, their bioavailability is increased. Food contact materials, well, they develop wax containing nanosilver. Remember, nanosilver have these antibacterial properties. Okay, applications for food quality. It's possible to develop attractive surfaces, as shown in the picture. Applications in packaging, of course, glaze and colors, attractive colors, components of food flavor, smell. That's the power of adding nanoparticles in food. And again, it's possible to extend the food product shelf life. Okay, let's talk a little bit about the detection of pathogens by using smart nanosensors, by using these well-structured nanomaterials, nanocantilevers, presenting very nice properties. The same as nanovirus, presenting a huge contact area, special to develop very sensitive sensors. Okay. This is an illustration of the use of they look like a tiny diving boat as a swimming pool, right? So these boats vibrate at different frequencies when contaminants stick to them, revealing in this way the presence of viruses or bacteria. So this frequency, vibration frequency, is sent to the detector of the sensor to interpret the information. Okay? Nanocantilevers. Again, I told you that these nanocantilevers present a huge surface contact, and it's going to be possible to develop very sensitive sensors. This is an illustration of the use of nanovirus, allowing again to develop very sensitive sensors. But it's very, very similar to ELISA, the method you have to know. Okay? The difference is that this method is very sensitive. Okay, other applications. Well, bioluminescence detection. So, in fact, nano-bioluminescence detection is great. So, there is a luminescent protein that binds E. coli, emitting a visible glow, which is necessary to develop this kind of sensor, bioluminescent sensor, to detect pathogens. Okay. Electronic thermometer. Well, they are composed of an array of nanosensors, very sensitive to gases, which are released. The gases are released by food as it follows. Very useful to detect non-fresh foods. Again, this consists of an array of nanosensors which are extremely sensitive to gases, causing the sensor strip to change colors as a result. So giving a clear visible signal or whether the food is fresh or not. Okay, so very smart nanosensor. Uses of nanosensor, well, it's very useful to detect and retard spoilage and the bacterial growth. It's also useful in monitoring time, temperature, and motion. Okay, let's talk a little bit about nanocomposites. Nanocomposites, in fact, are combined to plastic. In this way, product to increase the shelf life, so retarding the spoilage. And they are better at sealing CO2. So CO2 rests or stay inside in the bottle. They don't go out. And it's composed of a barrier to oxygen. So oxygen does not enter inside. So avoiding oxidation of the product inside of this improved plastic enclosed by the use of clay nanoparticles. Cellular packaging. Well, nanoparticles change color as milk goes bad. Okay. Silver nanoparticles also can be used in packaging to reduce bacteria by 99% approximately. Okay. Now another example of nanocomposites. Well, they work on a plastic wrapping based on the use of silicon nanoparticles. So adding silicon nanoparticles to the plastic wrapping is possible to these wrappings became lighter, stronger, and heat resistant. This prevents contents from drying out and under protection against moisture and oxygen. So magic packaging when added silicon nanoparticles. And now for a kitchen, it's a food contact material to develop kitchen boards containing nanosilver particles. Remember, silver nanoparticles have these words, antibacterial properties. Okay? And I'm pretty sure you love French fries. Well, this is an application of nanoceramics to reduce oil use by half in fat fryers. This prevents the oxidation and agglomeration of fats. So thanks to the increased surface area presented by these nanoceramics. And well, it's going to be possible to extend the lifespan of oil, reducing energy usage. Because the oil is going to be heated up more quickly, thanks to use of the nanoceramics offering a huge surface area. Okay. A little bit of environmental risks from nanotechnology. There are a lot of papers. I took just some papers here, 2 papers in fact, who talks about antibacterial nanofood packaging and nanosensor technologies. They say they may interfere with beneficial bacteria in our bodies and in the environment. That's true. It's possible. It's not a fact. Another paper talks about highly potent antibacterial nanomaterials to disrupt the function of beneficial bacteria in the environment. The example is in nitrification and denitrification in fresh water. So, well, it's true there are bacteria, aerobic or anaerobic bacteria, which are used to treat the contents of nitrogen by using these special procedures, nitrification and denitrification. So these beneficial bacteria can be interpreted. Yes, that's true. Okay. Well, there are a lot of aspects to discuss about the risks of nanomaterials. But I think no matter the risk in the near future are going to be proved, I think nanotechnology is here to stay. Because the application of nanotechnologies in food products and food safety will continue to grow. They're not going to stop. And another aspect to to mention is that there is by the time being little data about health and safety issues. So it's very difficult to say that nanoparticles are really very dangerous for us, for our health, or for the environment. Okay, to finish, I would like to tell you some very interesting websites you can check if you want to follow kind of news, fresh news about the applications of nanotechnologies in every sector. The first one, for instance, is very useful, the nanotechnology world. You can check even this in or through Facebook, Science News Magazine, and Phys.org is useful too. A book, well, this is a very interesting book, The Dance of Molecules, How Nanotechnology is Changing Our Lives. I recommend to read this. This book is really very, very interesting. Okay, to finish my presentation, I would like to thank, well, first of all, to Professor Gerhard Schleining, to Dr. Helmut Glatt, and also to Bioluminescence to make possible this webinar. And also I'd like to say thank you to the direction of the LaSalle Beauvais. Thanks a lot, Bioluminescence.
Thank you very much, Victor. It was a very interesting lecture for us. I told you before I also had some experience in nanotechnology, so for me as well. And you presented a very good overview on the applications with regards to agriculture and foods, which I'm sure everyone in our audience found something new in this lecture. And I would like now to deliver some questions to you, which were already sent through our question typing chat box. First, a few questions from Sibel Cardozo. First, she's asking, how can nanoparticles interact with the human system, with intestine, etc., in order to increase, for example, the absorption of nutrients?
Okay, that's a very interesting question. Okay, it's possible to develop the so-called nano devices, kind of capsules containing the chemicals, the drugs you're going to deliver in the bodies. So these devices, these capsules are biodegradable, so produces no problem in our bodies, and they can reach the precise site you want to reach. You want to put your the chemical or the nutrient you want to deliver. So these are the so-called smart nano devices. I don't know if this answers the question.
Yes, I think, because through these devices, indeed, we can make target delivery. Also, we can do slow delivery.
There are tiny devices so that they can answer our bodies with no problem.
Says it did answer her question. Also, some further questions, again from Sibel. For how long these nanostructures work on sea, water, and human body? Is there a necessity to apply them repeatedly? So how long is the function of these nanostructures that we use?
Well, it's difficult to estimate the time. It depends on what you want to carry in the nano device. It depends on the contents. It's a chemical, a drug, a nutrient. If it's a nutrient, well, that is going to be delivered in the intestine directly. So no problem in our tract, in our bodies. They are not going to affect it, but they are going to be delivered directly in our intestine. And then they are going to be, rejected in a natural way.
I see.
Well, estimate the time, it's difficult. No, I cannot answer this. It depends on the application.
Yes, so it depends. Okay. And again, a question from Sibel. What happens with these nanoparticles after being used, how they decompose on sea and water, and more importantly in the human body. For human body, you replied they are evacuated in the natural ways, but for sea and water,
you know, yes, okay. First of all, to say that nanoparticles are not applied, are not put, are not transplanted. I don't know how to explain in our bodies alone. They are part of other macroparticles. They can be embedded in other substances. So if nanoparticles are embedded, are integrated in other particles, there is no, how can I say, danger, no problem for these nanoparticles affect our organs, our cells, our brain, and so on.
If we treat soil and water for remediation, what would be a way to remove, how to say?
Well, it's not clear the question. You mean to treat polluted waters?
Yes, you mentioned such applications.
Yeah, I mentioned that it's possible to use iron nanoparticles. That's true, because they present, well, they are much more reactive. So they can oxidize pollutants in waters in an easy way. That's the purpose.
Yeah, but the question is what happens with nanoparticles after that, after there?
Okay, I have already told you this. In fact, nanoparticles are not applied in a pure state. They are also combined with other, for instance, surfactants, because you have to know that nanoparticles have this inconvenience to be agglomerated. So we need to, first of all, to fix the problem to agglomeration by using surfactants. So again, they are going to be embedded in the surfactants, so no problem for this. They are going to be rejected in waste waters or as waste waters.
Okay.
Unless you're going to drink the waste water, well, you're going to be problems, of course. But we don't drink usually waste waters, right?
Yes. Okay, understood. And how the cost of food would be increased due to the use of nanotechnology, and also for the agriculture, the use of nanotechnology, how would this reflect on the price of products?
Well, and
consumer?
the consequences of using nanoparticles, well, in terms of what price, yes, of course, the price is going to be reduced so much because we're going to be able to control the dose of pesticides or herbicides to use to control the growth of plants. So we're going to use just the necessary volume of these chemicals. So we're going to avoid, at the same time, the environmental pollution while lowering the costs. That's the purpose. So it's really amazing those applications in agriculture and also in the development of smart foods.
Yes, great. So it's actually good for the consumer too. The
price,
price
of course.
Yes.
Yeah, of course.
I mean, price-wise. Yes, the other benefits are obvious. And
yeah, of course, yes.
Thank you. And we have a comment from Liliana Tudoriano. She's our colleague from ISEKI-Food Association. And she says, the scientific community works together for the harmonization of tests for hazard evaluation of nanotechnology-based products over the various stages of their life cycle. And this harmonization involves the development of validated methodologies for exposure assessment on a quantitative approach at the different exposure scenarios that a specific product would undergo in normal conditions. So she asks, how do the nanotechnologies used in precision farming, for instance, aluminum nanoparticles or food, respond to these problems, which means evaluation of the risk of methodologies for exposure, etc.
Well, okay.
Can
it's
you
a general
give any
question.
comment?
Yes,
it's related to harmonization of tests for the risk evaluation of nanotechnology.
Yeah, that's a little bit, how can I say, a little bit away from the subject I'm talking to you right now, but I can give you some comments to tell you the risks of the use of nanoparticles. Well, are very important. I mean, we need to consider the risk. We need to talk about. We need to control the release of the nanoparticles. But by the time being, again, I want to come back again to tell you that nanoparticles are not used in a pure state. They are combined.
Yes.
They are combined with other elements. So, in my opinion, there is no problem. There is no danger for plants or for our bodies, for living entities.
Yes.
I don't think so.
And
all I can recommend is to control the release of this, to use nanoparticles in a precise dose to avoid spilling in the environment. That's a purpose.
Yes.
I mean, so we need to use that somebody called in a paper the precautionary principle.
Yes, I see. And with regards to this discussion, we have some inputs from other colleagues present at the webinar. You have special thanks from Hubert Rauscher. He says many thanks for the presentation, and he also advises our audience to go to EFSA report, Inventory of Nanotechnology Applications in the Agricultural, Feed and Food Sector. This inventory was published in 2014 and available online in the EFSA publications, in the EFSA website. When we go to publications, find it there. So it's for anyone who would who would like to see a very detailed inventory of the applications, they can go there. Also, Pierre-Luc Dupont is saying that with CP-ICP-MS, it's easy to analyze and control the presence in the life of organometallic or strictly metallic nanoparticles. So this is the technology to control the presence and answer the questions on how do we analyze. Also, he offers, for instance, several papers that were presented recently. And with regards to safety, the norms in the European Union are currently in preparation, and several works, several research teams are running into safety in the blood, in the serum, urine, organs. There are such research. Also to environmental samples to understand their behavior. So actually nothing is fully solved yet. A lot of research is going on exactly on the aspects of how to analyze and how to control and how to know what is happening to all these nanoparticles in our environment and also in their applications. So I think, yes, there are still, the norms are still under work, in preparation. They are not still finished because we need the results of all these studies to be completed and to know what is happening. Also, Liliana is saying that some useful information can be found at www.nanosafetycluster.au. So I think yes, it's an interesting discussion. Pierre-Luc Dupont is saying that the lobbying in nanotechnology applications and the industries who are using are really active. For instance, cosmetics is very much.
Yeah, there are a lot of applications. Yeah, of course, and I have never heard about negative effects by using nanoparticles in cosmetics. everybody knows that they are in cosmetics. I mean, nanoparticles are in cosmetics, but never heard about the toxic effects or effects in our skin. So, no problem with this.
Okay.
And
About
the toxicity, there is a lot of research. Hello?
Yes, yes.
Yes, I was just saying that there is a lot of research done about the toxicity of nanoparticles in human beings. But I think no matter, there are a lot of publications, a lot of work, our knowledge in this field is still embryonic. Yes. I mean, it's not possible to say by the time being that we need to ban the nanoparticles. No, not yet. Not yet, because we don't know exactly the fate of these nanoparticles, for instance, in our bodies. I know that, for instance, some nanoparticles, if they're inhaled in a, how can I say, in a state of pure nanoparticles, they are going to be rejected immediately by our immune system. You see, we have kind of army in our bodies. They are going to create a barrier for these nanoparticles.
Yes.
And this is why for making kind of research to say if some nanoparticles are bad for our bodies, they are trying to introduce in our bodies nanoparticles, but in a disguised way to prevent the action of the immune system. Mm-hmm. There are nice works that they are doing, in fact, but nothing is proved yet. There is no fact to say to ban nanoparticles.
Yes, we still need a lot of evidence and research results to make conclusions, really. When we think the nanoparticles existed before we found them, before we found out about them.
Yeah, exactly.
Yes. Also, Pierre-Luc is adding that cosmetics, that nanoparticles are present naturally, like titanium dioxide, but big names like L'Oreal, Dior are equipped to work on that topic with MED, DLS, ICP-MS, etc. And he says, yes, Dr. Acha, nothing is proven yet. So we are still to see what is happening in this field. For now, the benefits are numerous. We know many of the benefits, and that's why are these applications. For the risks, we still need to see. And Liliana says, very interesting discussion. Maybe we can have 2 more webinars on nanoparticles, fate and use in food and agriculture. I would say a very good suggestion. Yes, I think this area is very still.
Yes, exactly. But next time it will be wonderful if we present results. I mean, to discuss much more about the negative effect of nanoparticles results, because today is just a lecture. It's just an introduction to say, hey.
Yes, of course, we are opening the topic, and it's an interesting topic for everyone because
exactly.
Yes. So thank you, Liliana. It's a very good suggestion. We should proceed with this. Yes, I think it will be very interesting for all to get involved in this discussion. Yes. So thank you very much. Do we have any more questions or comments from our audience today? We had some problems with the sound, so I would like to say sorry about that.
But this was really sad during my presentation.
I think it's a matter of internet connection.
It's not good to be interrupted because I was very concentrated, so I distract my mind.
Yes, I know.
So anyway,
I think everyone understands that sometimes technology plays bad jokes with us, even with our best intentions. But,
yes, you're right.
So I don't see any other questions coming from
I have a question for everyone.
Yes.
Do you know that nanoparticles are already used in computers? You know, the silica nanoparticles to improve the memories of computers. It's very common. So why people don't ask about the toxicity effects of these nanoparticles used in computers? I don't understand. People does not care about it. But when we talk about other nanoparticles, they ask questions, knowing that these nanoparticles were already used. So the discoveries, the transistors, you mean, are composed of nanoparticles.
Usually people are somehow most, most concerned when they hear that something is ingested or with
exactly.
foods or something is directly applied in our body.
Right.
So I think
exactly.
This is usually the case about concerns. What comes into yes. So thank you very much. Any more questions or comments? I am waiting a little to see.
Just to tell, I'm going to tell to everybody, to people who are still over there, do not hesitate to contact me if you need additional information or much more details about some applications I showed you. Please contact me. My electronic mail has to be somewhere. I didn't put it here.
Yes.
I'm going to.
Well, this is the main one of the.
I'm going to show them.
This is one of the main purposes of our webinars, to put people in contact, the people who work in the same areas.
Yes.
For sure.
Yeah. So here it is. Here is my email. Please do not hesitate to contact me.
We don't see it yet, but Victor's email is also in the ISEKI-Food website where the webinars are announced. So for every webinar there is information. Here's the email of Victor.
Yes, it's over there. So, yes, I'm here.
And I hope we all stay in touch for the.
Yes.
Hello.
Okay.
We all stay in touch for the further webinars in this topic. I think it opens a good niche for discussions, for further discussions.
Yeah. Exactly.
Yes.
Exactly,
So,
you're right.
Thank you very much. Liliana says thank you. And she also says she's very interested to collaborate in projects about nanoparticles in food and agriculture. Great, Liliana. I think it's also...
Excellent. Okay.
We can...
So please tell Liliana to contact me, please. I don't know if
yes, she can hear you. Yes, and everyone is hearing you.
Okay, excellent. Please, Liliana, contact me. We want to discuss more about.
Yes, I think this is also a good benefit of these webinars and us coming together, because we can identify our colleagues with whom we could collaborate. So it will be great. And Liliana says thank you.
Thank you, Liliana.
So it's a good way to go.
And thank you also to the questions of I don't know if she's still there. Thank you to Sivali.
Yes, it's my pleasure.
Okay.
To keep everyone in touch. And thank you so much, Victor. Indeed, it was a very interesting presentation. I personally learned a lot from it, and I'm sure everyone found new interesting facts about these applications. Yep. This was, as you said, an introduction to the nanotechnology applications, and for sure we'll do our best to develop this topic through webinars and go into more details and more research about what is happening in this area. And of course, everyone who was present today and registered and was interested in topic will be notified about everything that happens in the future with these webinars. in this topic, and with other webinars, of course, which are
Yeah.
coming. So I would like to very much thank you for agreeing to present this lecture today. And I believe all this will develop into other collaborations as well. So
I hope so.
I wish to...
Okay, thank you. Thank you, Victor.
I wish to thank everyone for being with us today, and to wish you to have a good evening or a good day, depending on where on the globe you are now, because in Europe now it's falling the evening, in South America it's still day. So wishing you all the best until next time to everyone. And thank you very much again. And
thank you.
Thank you.
Thank you so much.
Thank you. And bye-bye for today. See you all next time.
Yes, bye-bye. Yes.
Bye.
Okay. Yes, next time. Bye-bye. Thanks. Thanks again.
Bye.